Hello everyone, my name is Ajay and this is Docker Networking Part 2 and we are going to focus on bridge and none. These are the two type of network drivers which we are going to see with live examples. If you have seen my previous video, we have discussed bridge, none and host. It comes by default. Then you can go for MAC VLAN overlay IP VLAN, and you have also options to integrate with third-party network plugins. This is container networking model. In short, you can call it CNM. It is all based on the network plugins. So here you can see this is my network stack. On top of that, I will have the network plugins. These plugins can be native, it can be remote. Remote means it's going to be the third party. And then you have driver for IPAM, which is going to be the IP allocation and the management. That is also native and remote. For example, you can integrate it with the IPAM info blocks for your IP management. Top of that, you are going to run a Docker engine. And top of that, you are going to run your network drivers. Here I have mentioned network bridge 1 and bridge 2 since I'm only going to talk about bridge networking here. And these network bridges are going to be attached with endpoint that is going to be the part of containers. So container 1, it is having the endpoint 1 and this endpoint is attached with first bridge. And second example, you can see my first endpoint, it is attached with my bridge 1. My second endpoint is attached to bridge 2. Similarly, the third container is endpoint is attached to bridge 2. These are famous three network third-party plugins supported by Docker. Conti, basically it is used for Cisco. This one is used for OpenStack. So the question comes, if in Docker we already have a network functionality provided by the networking drivers, why do we need third party? So everything is all about scale, security, and different controls. So it's just not the connectivity. So these are the third-party plugins developed by the open source community to match basically the requirement which comes from various scenarios. Let's start our hands-on. So first thing, you need to verify whether the Docker is installed or not. This is the machine. Don't get confused with the host name. I just named it a Docker. This is a Linux Ubuntu machine running on Azure Cloud. So you can pass a command docker hyphen hyphen version that is going to tell you whether the Docker is installed or not. If it is not installed, it is going to pass this message that Docker not found, but this can be installed with this command. Let's verify our host for the IP verification. So you can pass a command ifconfig, and you can see on this machine Ethernet 0 IP address 10.0.0.4 that is assigned, and the net mask is going to be 255.255.255.0. You can see a loopback. This interface comes inbuilt, and we are going to expand all these things going forward. The second command which you can fire is going to be the ls slash sys slash class slash net, and it is going to tell you how many interface exist on this host. So you can see first, second, and third. It's exactly the same thing what we have seen from ifconfig, but passing additional command which is going to be sudo ls hard hw, which is hardware hyphen class network hyphen short. That tells you two interfaces. This one is the Ethernet interface where we see the IP address is assigned. This is going to talk about the physical properties. So it is MT27710 family, which is the Mellanox. So from here you can guess the physical hardware is going for NIC is going to be the Mellanox. Now I have installed Docker on this host and I can see it is running a 20.10.12 version. I have not demoed how to install it. If you have not seen installation, please refer to my previous video. So once this Docker is installed, you can fire the same command, which is going to be IP address show or if config, both works fine. And you can see there is an additional interface. What we can see here is Docker 0. The next command you can pass, which is going to be the Docker space network space ls, and that is going to list down all three type of network drivers. Those are going to be the default. And why do we see only three? And the reason behind, we are talking about the standalone networking on a single host. The rest of the drivers, they will reflect when you do the networking in a cluster. So bridge is going to be the default network type the moment you launch any of the container. Then you have an option for the host, and then you have an option for none. And we are going to see how all this works. But in this section, part 2 will be more focused on the bridge. So let's talk about the Docker bridge. As we have seen earlier, the moment you install the Docker engine on a particular host, it is going to create a default bridge for you, which is going to be Docker 0. Any instance of container you launch without specifying the network, they are going to be the part of the same bridge. So container 1, container 2, container 3, and 4, they are going to get the IP address from the range which is assigned to this Docker 0. So Docker always launches your container and this network. This is how you can visualize the whole concept. So you have a host. This host can be a standalone unit, or you might be running a VM based on hypervisor. So this ETH, you can consider this as a physical NIC, which is connecting to your external world. On top of that, you are going to have a Docker 0 bridge attached. And this Docker 0 bridge will be attached to the container, and container will have a virtual Ethernet. Let's verify these things on a host. So first thing, you need to verify whether you are running the Docker on this host or not. So yes, we are running it, and that's the version 20.10.12. VRCTL show. That's a Linux command which basically tells you how many bridges you are having on this particular host. So after running that, you can see this bridge Docker 0, that is something created from the installation we have done for the Docker. So technically you have one bridge which is part of this host. The second command is going to be the Docker network inspect bridge, and that is going to tell you the name is bridge for this Docker 0. This is the ID. It is created on this state. The scope is local. Driver is bridge type. IPv6 is not enabled. And for native IPAM, you can see the subnet which is allocated to this bridge is going to be 172.17.0.0/16, and the gateway is going to be 0.1. So the moment you create a container, it will start allocating the IP from 2 onwards. So one is going to be the gateway, 2 onwards, the IP range can be associated or allocated to the containers. To demonstrate the networking on Docker host, I created 2 containers, C1 and C2, and they are nothing but Ubuntu process. Now, if you run the same command again to verify the bridge, it tells you there's a one bridge exists, which is Docker 0 with bridge ID this, and has two interfaces. So that is what is expected also. Now let's run a command docker network inspect bridge. This portion, it was already existed. I already explained you. Now we can see under the section container, there are two container edges. One is C1, second is C2. And for C1, the IP got allocated is 0.3, and for C2, the IP allocated is 0.2. If you're running multiple container or a particular host, the one thing you always want to verify how many containers are there and what are the IPs allocated. So there's a command docker network inspect bridge hyphen format, and you can do mix and match. So here it is going to tell you the containers and the name, and the output which you are going to see is going to be your container ID and the IP is allocated to that. Similarly, you can run docker ps hyphen format table ID and name. So it is going to return the container ID and the name of the container instance. Another command you can also check, if you say docker inspect, this is going to be the container ID format network setting dot network dot bridge. So this bridge is something which is coming from here, and the IP address. It is going to return you the IP address, which is basically associated to that particular container which you specified here. So there are multiple ways, multiple filters you can use along with this command. I have not come across any single command which gives you one-to-one mapping, like this is a container ID, or maybe this is a name and this is the IP address. So try to play with this command. You might come up some good ideas. Let's verify the connectivity between these containers. So I'm inside this container, which is having this container ID. And the moment you try to ping, that is the first thing is expected the ping command not found. And the reason behind these are just the processes. These are not the full-fledged running OS. So what you need to do, you need to run this command, which is going to be the apt update, which is going to update your repository, and then install apt install iputilities-ping. Once you are done, your ping is expected to work. So let's verify the connectivity now. This is my instance C1 and it has got the IP address 0.2. This is my instance C2 and the IP address is 0.3. Look at the container ID. Now I'm inside E4E. That is going to be the C2. Look at this. How to attach it? So there are ways. I'm using exec commands, so docker exec -it c2 bash. That takes me to the bash or inside the container. So now from here, if I ping, and technically my IP is going to be .3, so I need to check the connectivity for 2. So I'm going to ping 172.17.0.2, and this time I see there's a success. So two instances. One is attached to same bridge, second is also attached to the same bridge, and they are going to be part of the Docker 0. Now let's try to verify the connectivity to the internet from these containers what we created. So if you launch a ping command and go and ping the internet IP, which is 4.2.2.2, in my case, I get the success. And that is a meaning there is a internet connectivity which exists. So how it works? It has to be natted somewhere on your physical NIC, and that natting is something done with IP table. So look at this section, and it is telling you from the source, destination, it is all allowed. Your networking, which is going to be the part of the bridge, Docker 0, it is not limited to one particular bridge. You can create as many you want. So it is going to be your design, whether you want to allow some of the containers, which is going to be part of this particular bridge, to reach out to internet, or maybe you want to restrict it. So it is like the legacy networking concept only. So you can create as many as bridges you want. So let's try to create one bridge. So I'm going to launch a command docker network create hyphen hyphen subnet, and this is the subnet I'm going to use it. And the name of the bridge is going to be the no internet. And the reason behind, I wanted to test the moment I create some container on this particular bridge, they should be restricted for the internet access. So this bridge is successfully created. Now, if I launch a command docker network ls, it is telling you there is a one more bridge exist, and it's named as no hyphen internet. Now, since we created the bridge, if I launch the same command again, which is going to be the IP table hyphen hyphen ls hyphen t nat, what do we see? There's one more entry got added. So technically, that means any new bridge what you launch, they will have full internet access by default. This time I'm going to create a Ubuntu container with the name of C3. That's going to be the third instance. And I'm not specifying any network as such. So let's verify. You can see I'm running 3 instances. Since I have not mentioned the network type, network driver, or bridge ID, it is going to launch this instance as a part of Docker 0, the default bridge. Even though while creating the third instance of container, we have not mentioned network, hence it was part of the default bridge. You have an option, you have commands, you can disconnect it from one bridge, attach it to the second one, like that. So let's understand that. So the command network, docker network disconnect bridge C3. What it is telling you, disconnect C3 from a bridge is which is named as bridge. And the second command, connect C3 to a bridge which is named as no internet. Let's verify that. So Docker network inspect no internet. This is the bridge which was newly created. We had mentioned the subnet is going to be 172.19.0.0/16. And what do we see now? There's a one container which is named as C3. It has got assigned the first IP address from the range. Now let's test the connectivity. I'm inside this particular container, and if I try to ping instances on old bridge, which is C1 and C2, it fails. And that is because of the isolation. It is not expected to work until you do some tricks. When I ping for the internet, it works. So these are going to be the default setting, and those are working as expected. So the scenario what we have discussed is something you can visualize like this. This is the host. I created Docker 0 while installing the Docker engine, which comes by default. And then I created another bridge, which is no internet. And this container was attached to no internet. And this container, though there were two containers, basically, one more container was here, which was attached here. And we were not able to ping from each other. However, for internet connectivity from this container, it worked fine. And there was purpose I named this second bridge as no internet. And the reason behind I wanted to test some connectivity while restricting access to internet. So what I'm going to do here, I will put a filter where you're not going to have the ICMP reachability to internet. So let's try to test that. Now let's play with IP table and what we want to do, basically the new bridge what we created, I should not have the IP reachability on protocol ICMP. So I'm going to insert this command basically, which will reject all the ICMP. So sudo iptables hyphen hyphen insert docker hyphen user. This is going to be the source, which is going to be the full scope. Reject, reject with ICMP port unreachable. And you can see this entry here got added. And now if I get into my container, which is attached to no internet bridge, if I try to launch the same command again, which worked earlier, ping 4222, I see destination port unreachable, and that is exactly which is what we have done here. So you can play with the IP tables, you can restrict the access, etc., etc. Let's now understand how you can have the multiple endpoints attached to the containers. So Docker inspect bridge, it tells you you have only two container, C1 and C2. And when you run this command for second bridge, which is no hyphen internet, it tells you there's a one container attached, which is named as C3. Now run a command docker network connect no internet C1. That means I'm going to connect this instance of C1, which is attached to old bridge. It should connect to this bridge as well, which is named as no hyphen internet. So let's verify now. If I verify on no internet bridge, I see I got C1 attached here. So technically, C1 is here, and when you do the inspect for the bridge, C1 is also here. So it has two endpoint. One endpoint is having the IP address 172.17.0.2, and the second endpoint is going to have 172.19.0.3. You might have your private repository for container instances on Docker Hub. So you can use Docker login from the command prompt. And once it is successful, you can basically pull or build those Docker instances, container instances, basically. So let's try to launch Nginx. And I'm going to test the connectivity for web. So we have tested outside connectivity. Let's test inbound. So I'm going to pull Nginx image, which is the command is going to be the sudo docker pull Nginx. And if I'm not going to mention any of the tag here, it is going to be the latest image from Docker Hub. So now this image is there in my local repository. Now I want to launch a container. So Docker run, I want to name this instance as web. This is going to be the host port, which is 80. This is going to be the port 80 on container side. And I want to launch this for Nginx. If I run the command docker ps, I can see my third instance, not the third, it's the fourth instance, which is launched successfully. And this is the kind of traffic redirection you see. So anything which is hitting on host port 80 should be redirected to the port 80 here on container. As I mentioned earlier, I'm running this host on Azure, so this is going to be the public IP address. In firewall, I already allowed port 80. So if I'm going to test it from the internet, just by typing HTTP, and this is IP address colon port 80, I see my Nginx process, it works. Thank you for watching, and I will see you in the next video.